Today's project is Caterpillar 262D, little skid steer. Customer states there's a fuel leak. The front auxiliary hydraulics do not work. The front work lights do not work, and there's a caution light on. Now, anytime you come across a piece of equipment and they say fuel leak, don't start it up. Don't work on anything else. Immediately figure out what the fuel leak is, because diesel is hard to catch on fire, believe it or not. If you guys have ever tried, it's very difficult. You have to heat it up, but it can still catch on fire, contrary to popular belief of some people. So you want to make sure you're not spraying diesel onto the turbo, and you get, as a mechanic, you just hop in, you start it up, start doing all your testing and everything. It gets nice and hot, and the fuel leak suddenly got worse, or the owner wasn't really clear about how bad the fuel leak was. So let's go back here and check to see what we have. Now, these little 4-cylinder Caterpillar engines, little C3.3B, your fuel tank. It's kind of a dual saddle fuel tank. It's one tank, but it starts over here, goes down underneath the engine, comes back over here, and then your supply is right down there. You can tell, you see where all the wet dirt and everything is? That's a solenoid fuel pump. Basically just has like a little bitty plunger in there. Whenever you turn the key on, you can hear it click, 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 click. And it's just oscillating that fuel shuttle valve up and down, and there's a check valve at the top. So something on this guy is leaking. Might just be this hose right here. It might be the fuel pump itself. I'm not sure. Got to get it cleaned up, take it apart. Doesn't look like the fuel leak is all that bad. Most likely it's probably just this rubber hose right here, but still need to check and verify. And as a rule of thumb, before you ever do anything to any engine, any piece of equipment, when you first start working on it, I don't care if you're only there to fix the work lights. That's your only job. Check all the fluids in the engine. Check the engine oil. Check the coolant. Because crazy things happen. Owners forget to check their fluid levels. They forget to tell you about that massive oil leak. They forget to tell you that you got to put 2 gallons of oil in it before you ever fire it. And you come out there, you start it up, you run it without oil, you run it without coolant, and then you're going to have a problem. The owner's just like, oh, well, you cost me an engine. And well, it wasn't your fault, but you need to check that stuff. Today, I'm really glad that I'm doing that, and I'll show you why. So we'll check the engine oil. We got plenty of engine oil, looks all right. All right, look at that coolant reservoir. That thing is empty. I'm gonna pull this top cover off, and we're gonna pull that radiator cap off, and we're gonna look down in there and see if we have any fluid. So I've got the engine running. Check out this fuel. See how aerated it is? That's not good. Something on here is leaking. I take that fuel filter apart and see if there's an O-ring or something, or just this fuel line. Probably going to go ahead and replace this fuel line, turn it back on, and then see if we can get rid of those bubbles. So most of your newer diesels use high pressure fuel, and the problem is when you have those little bubbles in there, they call it air entrainment. Those little bubbles cause cavitation into the fuel system. Your high pressure fuel pump is supplied with fuel pressure with those the fuel that's got little bubbles in it, that air entrainment, and it compresses it. And whenever you compress, it squeezes it down, and anytime you compress the gas, it heats up. And eventually we get to the point where it kind of causes an explosion of steam, and it can pockmark, it can remove metal, make little divots. And you see this on propellers on ships all the time. If there's cavitation, it causes these little bitty explosions. Your high pressure fuel pump doesn't care. It's just going to suck fuel into it and compress it to higher pressure. If that gets to your injectors, then you're going to have a problem. So before I pull that fuel filter off, I'm going to go ahead and hook up Cat ET real quick and see what kind of caution light we have on, just to make sure everything else is running. Doesn't appear that there's any problem with the coolant system. Might have just gotten it too hot one day and it expanded so much that it purged it out. But it's I need a little more diagnostics on that. So let's see what kind of code we got. Company Ansel sent me their HD 3600 scan tool. And this thing is supposed to communicate with off-highway equipment. It's supposed to do functional testing like regens, some system component tests, and read codes. And just to be honest, I've had several companies send me stuff before, and none of them have worked, especially on Caterpillar for some reason. But we're going to try this today. Now the set that they sell you does come with a specific Cat 9 pin connector, and the Cat 9 pin is not your standard 9 pin that goes on like 18-wheelers. And all you do on a Caterpillar, you have this fuse panel right here, pull your cover off, got your 9 pin connector right there, stab her in the hole, and wait till she fires up. We're gonna go to Caterpillar, Cat 9 pin, construction machinery, CDL. Now CDL is for the interface. On Cat ET, you have a COM adapter, and that's basically all it's talking about. So it's going to let us do machine control, read fault code, read the diagnostic code, read active DTC, auxiliary joystick position number 1. Okay. We'll read our history DTC. Power supply, lift cylinder head pressure, drive control relay, loader bucket inclinometer, sensor voltage low, bucket inclinometer. All right, go back. Let's read our event codes. We got a lot of codes, but you got to look at the time. That's at 571 hours, and right now we're at 45:48. Low system voltage. That's pretty normal for construction equipment. So that's pretty cool. It gives you all the machine control. Now, one of the problems you have with communicating with Cat equipment is that if you use a communication adapter, you can only communicate usually with the engine. If you have a Cat COM3 and you're using Cat ET, you can communicate both of them at the same time. But if you're using something like a Nexic USB Link 3, then you can only access one module at a time. As far as a handheld scan tool, this is the only one that I've ever ran into that can actually read the machine. There's a shit ton of them out there, and the only thing they'll do is just read the engine, and you're SOL with the machine controls. So we're gonna go back to our communication adapter. So that was CDL, which is gonna be a machine. Now we're gonna go on J1939, which is gonna give us our engine control. All right, so we have a C3.3. We wanna read the fault codes, read current fault code, no fault code present, read history fault codes. Doesn't appear we have any history. Yeah, hit OK. We have one that's undefined. Now we can take that number and look it up on the internet, and I want to do pending. No codes. Now I want to see if we could actually do a forced regen with this. So we went back to our options, go down into DPF J1939, see if we can get any communication. So we can, got a couple options here. We can read ECU information, software, ECM serial number. Go to read data stream. It's going to let us do engine starting, throttle, fuel usage, DPF performance, fuel pump, and it will give you the values. Going through reading our pyrometers, our soot load. We're at 66%, so we probably need a active regen. Going to get that down for the customer. Now for this model of machine, doesn't look like this scan tool has the ability to do a forced regen on it. I don't see any options to do a forced regen. Now the HD3600 does say that it will do some forced regens on equipment, but I don't know if there's a comprehensive list if it'll do forced regens on what particular equipment. As I come across equipment, I'll try it out and show you guys. But as far as an active code reader that'll get you all the data and let you do some diagnostics on machinery, and specifically your own piece of machinery, it's not a bad setup. I think it's like $700-800. You can read clear codes, and that'll get you by, and like 99% of the time you don't really have to have the rest of it. Now if you're a full-blown heavy equipment, you know, field mechanic or a shop mechanic, you work on this stuff all of the time, then yes, you are going to need something a little more comprehensive than that. But even field mechanics, like sometimes you just don't want to drag your laptop out just to figure out one particular code. So in that case, having a little handheld set like this, a little plug and play, works pretty good. Pretty surprised that this communicated with Caterpillar. I've had TopDon send me one of their scan tools, and it was supposed to be the latest and greatest, big bad, whatever, and communicate with everything, and I couldn't get it to communicate with nothing. Wouldn't communicate with John Deere, Caterpillar, We communicate with some on-the-road trucks, but they specifically sent it to me for heavy equipment, and it didn't work on any heavy equipment. It was like a $6,000, $7,000 setup. But, you know, 800 bucks, 700 bucks, whatever the price is, not a bad little unit. If you guys want one of these, look in the description down below, click on that link, go over and buy you one. If you have used one of these or you're interested in it, throw it down in the comments, let me know. So that code, the 22034-3, was for the auxiliary lever is what it calls it. But what it is, on the joystick on this side, you have this thumb wheel. And if it's not sensing this thumb wheel, it won't let you engage auxiliary hydraulics because it doesn't know where the thumb wheel is at. So to test that, so we need to back probe our wires. The yellow wire right there, which turns into a white wire down to the sensor, is our 8-volt supply. And then we have our white and green wires. The white one's going to be the ground. The green is going to be our signal. It's going to be the brown and yellow wire on that side of the harness. It drives me insane when manufacturers do that. Like one side of the harness will have one color, and the other side of the harness will have another color, but you can't do anything about it now. Unfortunately, I broke my voltmeter the other day, so I don't have a good voltmeter, but I do have my Power Probe 4, and I can measure pulse width. So I should be getting some sort of sweep voltage when I move this up and down, and I'm not. It tells me that I have an open in this switch right here. At least that's what I'm thinking. There's a couple more pinpoint tests or pinout tests that I'm going to do. I'm going to disconnect this guy. I'm going to change my mode to voltage. Show you guys when I'm back probing that white wire, which is the yellow 8 volt, and I'm getting 8 volts. If I back probe that one, which is my white, my ground, I do have good ground. And my next test is to disconnect my sensor, the little thumb wheel and the trigger button. Back probe my white and green wire, which is my ground and my return to signal, and I should be getting just any voltage. Now, Caterpillar doesn't give you an exact voltage, it's just looking for some sort of voltage. It's kind of frustrating when you're reading the manual and it tells you something like that, but any voltage is within spec. Read here, key start with switch on, harness for the sensor. Now on step 2, we've already disconnected the sensor. If the signal circuit and the return circuit for the sensor is correct, the ECM pull-up voltage should be indicated on the voltage measurement. The value of the voltage can vary. The presence of voltage will indicate that the signal circuit is not open. The absence of voltage indicates open in the signal. Now, the only thing about that test that's kind of frustrating is if you read the manual, it doesn't specifically say on that test if the sensor is supposed to be plugged back in or if you're just supposed to leave it unplugged. Now, a lot of times if you're at step this one on, in this case, it's step 2. If it says on step 2 that you need to disconnect the sensor and then move on to step 3, you just you continue that process. You don't replug stuff back in. And you can tell, check voltage at the sensor. That's what we just did. We got that 8 volt supply voltage off that yellow wire. Disconnect the sensor from machine, yellow to white. That's our yellow, that's our 8 volt positive and our ground. And if you scroll down, it says proceed to step 3. Go down to step 3. Key start, switch in the on position at the machine harness connected for the sensor. Measure the voltage from signal contact wire, contact 3, the green to the white. It doesn't tell you, but we do have voltage there, so we can proceed to the next step. So out of curiosity, I went ahead and plugged the harness back in, lift my back probes in a white and green wire, and we're still getting 5 volts. Now maybe I'm reading this wrong, I don't know, but it seems to jump, this repair procedure seems to jump and not doom the actual thumb wheel sensor. It's just a little magnetic wheel sensor, and it doesn't tell me, oh, okay, well, if all these other things checked out, it must be this. So we've checked our duty cycle. Go down to expected results. It says not okay. The duty cycle values are not correct in range, blah, blah, blah. Proceed to step 2. So we go down to step 2. This is disconnect the sensor. We're going to check voltage at the sensor. We checked voltage at the yellow wire and white wire, the positive and ground. We had 8 volts. The voltage measurement is 8. Proceed to step 3. Go down to step 3. At the machine harness connector for sensor, measure the voltage from signal contact 3, the green wire, to the ground in white. Results: the pull-up voltage is present when the measurement is performed. The signal circuit and return circuit are correct. Again, in this step, it doesn't tell you what the correct voltage is. It doesn't give you a specification. It just says the presence of a voltage will indicate that the signal circuit is not open. The absence of a voltage indicates an open in the signal circuit. So since we've done all our pinouts, and I back probed that green wire, which is our signal return, looking at the pulse width frequency on it, and every time I move that switch, I should be getting some sort of different signal that I'm not. It tells me that between the yellow and white wire, there's an open. Now, unfortunately, this sensor is potted. Can't really take it apart. I can take the top off, but that's really just a housing for this little rocker. And there's a magnet on the bottom of that rocker that moves past the Hall effect sensor. I was hoping I could find some sort of part number on this guy so I could order it instead of ordering a whole joystick, because the joystick's about $1,300. But it's going to need that little thumb wheel, and they're pretty common to go out on these, so I'll tell the customer what the issue is. Now, I think there's some companies out there that actually repair these. They can replace that thumb wheel. I've had kind of questionable luck with sending the stuff out. If you guys know a good source for that kind of thing, let me know. I'd love to be able to actually trust a company. So I sent some components off to different repair places, 3 different ones specifically, and never got my stuff back. I guess it seems to be pretty common. Or I've had one instance where I sent a component to somebody, paid them for the diagnostic fee, and they couldn't fix it. So then had to pay for the shipping there, the diagnostic fee, and the shipping back. So, it's $800 to tell me that, oh, well, we don't work on these kind of things. So anyway, I'll move on to the next problem with this. The next problem is these lights aren't working for some reason. Sitting here, these should be lighting up. That little indicator right there should be doing something. So we're going to check voltage to our fuses back there and see what we got. Easiest thing to check, one, is look at the bulbs. And these bulbs, you can actually look in the inside. You're looking for those little spring-looking things, a little filament inside the coils, and they should look uniformed all the way through. If you see them kind of like split, and obviously not making contact, then that's a problem. Didn't notice anything on either one of those. Sit inside. Right now, I have my switch turned on, and I don't have any power. If I back probe that purple wire out there, it's getting voltage to it. But just sitting here playing with this, I figured out, it tells me it's most likely a relay. The little contacts in the relay get carboned up, and that open, close, open, close, open, close will either heat that circuit up because of the carbon built up, the resistance it's getting, and it'll start making contact, and when it cools off, it won't make contact, and the more times you supply voltage to a relay and take voltage away, and you keep doing that over and over and over, it sits there in a little contact, and sometimes that wears a little pad. So need to figure out where the relay for this is, but I think it's up underneath the cab. For whatever reason, they didn't do us any favors by putting the relay in here. At least I don't think those are the relays. It says horn, gas, and whatever that roller is. But just out of curiosity, I'm going to swap these 3 relays around and then try this again to see if my problem goes away. If it does, and I know, even though this is telling me, because of the little picture, say it's not, then that was it. So I figured out what the light problem is. This switch sometimes sends voltage to this pink wire, sometimes it doesn't. Gosh dang. There's an aftermarket door that was installed. And the problem is it swings open too much. That hinge hits that and it just breaks this. It's gonna break off completely eventually. Anyway, needs a new switch, so I'll stick the back up in there, order another switch, get it on. So switch, new joystick, new fuel pump, leaking pretty good now. And I've got one more project on this skid steer that I need to take apart off, but I'm gonna make a whole nother video about. So that's it for today, today's video on this. Hope you guys liked the video. I don't have any parts on hand, so I'm just going to go ahead and end the video there. Order the parts, get them back. I'll make an updated video about installing everything. Show you guys that process. Hope you liked the video. Hit the like button, hit the subscribe button, and then get out and fix something.